Hello, and welcome to the first of hopefully several Unity workshops hosted by the UWF chapter of the ACM. Today we're going to make a simple version of Pong. This tutorial is very much for beginners, people that just want to get into Unity, haven't really before. Though we will be writing some scripts, so any knowledge you may have of coding, especially in C#, will come in handy. I will do my best to explain as I go, but if you have any questions, feel free to leave a YouTube comment or email us. There's always no shame in Googling anything you don't understand. So, once you have Unity downloaded or installed, we will have a link in the description for that. You want to go and make a new project. We're going to make a 2D project. We're going to call it Pong, though you can call it whatever you want. And you can also save it wherever you want. But I already have a project loaded up, since Unity usually takes a couple minutes to start up, so while yours will be, I'm just going to real quick explain what these four main windows are. If your Unity starts up and you do not see all these windows laid out like this, you can go in the top right here and click on Default. That'll reset all these windows to their default. So, the hierarchy up here, it is what this window is called. It simply holds pretty much all the game objects that are currently in the scene. So the only thing right now is the camera, which is what Unity always starts with. The camera is pretty much what the player will see when they start the game. This is the scene view. This is what your game world actually looks like. If you want to see it from the player's perspective, you can click on Game up here, and it will show you what the camera sees. Clicking on the camera will also show a nice little camera preview. This is the inspector. Pretty much anytime you click on an object, either in here or in here, it will show all of the little aspects of the object over here. So for example, a camera has a transform, a camera and an audio listener. Pretty much that just means transform is where it is in the space, camera is what actually lets it be a camera, such as record and whatnot, and the audio listener is what, like, if there is audio playing, the camera would be able to actually pick it up. But we don't have to mess about any of this. We're going to leave all of that as the default for now. This is the assets folder. Pretty much this is where all your actual computer files will go for your game, such as sprites, audio tracks, any models you have if it's like a 3D game. Pretty much everything that you would save on a disk is in here. So speaking of that, we're going to make our first new thing for this game. We're going to right click in the assets folder, go up to create, go to sprites, and go to square. And we're going to call this square a paddle. So now that we have our paddle sprite, we can simply drag it into the hierarchy view to get it put inside our game world. Of course, we can also just drag it straight into the game world itself. Either way will work. So now that we have it in here, we need to look a bit more paddle-like. Right now it is simply just 1 by 1, which 1 in Unity just means 1 Unity unit. It's not like meters or anything. It's just a arbitrary unit you has. But we don't want it to be a square. We want it to be a more paddle shape. So we're going to make it 2. We're going to make it 0.5 by 2. That is much more paddle-like, something you'd expect from Pong. So now that we have one of these, we're going to get into scripting. Unity, whenever you install it, should recommend that you get Visual Studio Community. Probably 2019 right now, to help edit your scripts. I highly recommend it, as it comes with a lot of nice little tools that work especially well with Unity. I have Visual Studio Community 2017 installed, but it should get the purposes done pretty much just the same particular project. So in order to make a script, we're going to right click on our assets folder again. We're going to hit create. We're going to go to C# script. We're going to call this script the paddle controller. It is very important that whenever you make the script, you do not forget to name it. So let's say you accidentally named it like paddle controllers, or just some gibberish. If you click on it, you can actually get a little preview of the code. And as you can see, it actually made some of the code change based on what I named it. So I would have to remember to change both the name of this file and that code if I wanted this to work properly. The best way is that if you mess up naming a C# script, just delete it and make a new one. So paddle controller. So now that we have this, we can double click it to open up Visual Studio. It'll take us a couple seconds to open up. It may mention that some of your .NET frameworks don't quite add up to the newest versions. That's fine. I've never had any problems by just ignoring that. Maybe in more complex projects you might, but for what we're doing, it doesn't matter. So it will start off giving you these two little functions called update and start. They do exactly what these little comments tell you. Start is pretty much called as soon as you hit the as soon as your game starts up, everything in this block of code will be run. So for example, if we wanted the object to move to a specific position every time, or anything to do with initialization, will be done here. Luckily Pong is so simple, we don't actually need to initialize anything. Instead, all we want is pretty much to make our paddle move, hopefully with player input. So the first thing we're going to do is to get it to move at all. In order to do that, we need something that's called a vector3. So what a vector3 is pretty much, it is given to us by this Unity library that Unity very nicely includes by default. And all it is a collection of 3 values, pretty much an x, y, and z coordinate. So if you've ever worked with grids before, it should be pretty simple to imagine. In Unity, it's made of grid. It is a grid, a 3D grid, though we only care about 2 dimensions since we're making a 2D game. And as you can see, every game object has a thing called a transform. Pretty much a transform tells you where it is in space, how it's rotated in the frame of reference of the space, and how it is scaled in the space. So for example, our square is currently at position that, and 0, z. Z is the forward and back, if we're to zoom in and out like that. And it's currently not rotated at all, and it's currently scaled as we made it to make it look more like a rectangle. So we can actually edit this in our code, but we need, the transform is made up of vector3s, so we need a vector3 to edit it. We're going to make a new vector3 called pos, short for position, and it is going to be equal to this dot transform, which we just discussed. Every object has a transform, and every transform has position. We could, of course, also edit, like, say, its rotation, for example, but right now we only care about moving it, not making it look funky. So now, what this means, so at the start of every frame. Oh, and those of you that might not know what a frame is, pretty much, it's something that happens every instant in the game. So you may have heard of something like 30 or 60 FPS. That stands for frames a second. And so pretty much Unity defaults to 60 FPS. So 60 times a second, this function will get called. So 6 times a second, we're going to grab where the paddle currently is, which will be helpful because now we're going to take that position that we just grabbed. We're going to take its y value, which is the vertical, so the one that makes it go up and down. We're going to add to it 1. So we take the y position of where the paddle currently is, and we set it to equal to 1 itself plus 1. Now plus 1 is actually a lot in Unity. If you go back to it, you can see that 1 is pretty much this whole block, so it going up 60 times a second is kind of fast. So we're going to slow it down slightly. We're going to make it actually just go up. Let's say 0.1. When using decimal numbers in C#, it will not recognize it because it doesn't know what the heck you mean by this period and then a number, unless you tell it, oh, it's a float. And floats pretty much just means decimal numbers in C#. So every frame now, we're going to get the initial position of the paddle. Then we're going to edit that position by adding plus 0.1 to its height, pretty much. Now, so all we're doing right now is editing a variable. We're not actually editing the transform of the paddle itself. So in order to now set this new position we have to the paddle, to make the paddle move to this new position, we do this dot transform dot position again. equals to just position. So we get the initial position, we edit it a little bit, and then we set the new position to be that position. So, but how do we know that this is referring to the paddle and not just any other possible object? That's where these little modules that Unity objects have come in. So we're going to add this script to the paddle. There's a couple ways we can do that. We're going to do that first way by just hitting add component. Then we're going to search paddle controller, and it pops up right there. Click on it. That adds it to the thing. If you want to see the script run in action, these nice little preview buttons Unity has up here. You just hit play, and we watch the paddle slowly fly up the screen. Something very important to note about the play mode is that while you're in play mode, you can make changes to stuff in Unity. Or if I go back to scene mode, I can say, oh, I want the camera to follow the paddle. So let's make its Y go way up so until we find the paddle. Oh, there it is. It's still going, still going. Then you go back. Everything resets. Nothing is saved while in play mode. It's very important to keep that in mind, because if you make any changes, you really want them to save. Doesn't matter how many times you hit Control S, they get erased as you go out of play mode. It's by design because it lets you playtest things very easily without having to worry about messing up your stuff, but it can get annoying when you make a bunch of changes and forget you were in play mode the whole time. So make sure to avoid that. Speaking of saving, make sure every time you make any changes to your script, you hit Control S, as if you don't, Unity won't know to recompile your script, and it won't know to update it, pretty much. So like if we make a change here, like let's say, oh, I wanted to actually move 1, which is really fast, but I don't hit save. You can know I didn't hit save because this little star is up here. You can hit play, and it'll still move at the slow speed. So I'll be like, oh, I forgot to hit save. Go back, hit Control S, little star goes away, and you'll see that the Unity takes a little bit to recompile, and it just shoots off in the sky. Obviously that's a little unplayable though, so we're gonna go back to what we had before. And save again. So now that we have a paddle that moves up, but kind of unprompted, let's see if we can make it so that way it actually listens to player input. So we're gonna write an if statement. If input dot get key, and then a key code dot up arrow. So and then we're just gonna cut our code we wrote for this, paste into here. You will see that now, so for those of you that don't know how to code, an if statement pretty much is asked if this, so if this is true or false, such as like if 1 equals 1, then do this. And what this is so input is another nice class that Unity provides for us that pretty much takes care of all user input, mostly keyboard and mouse stuff. Get key is a function that pretty much lets you give it a number related to a certain key and tells you whether that key is up, down, or currently being pressed. And the key code is pretty much what helps us get the number for that key. So we don't know what number up arrow is. Apparently it's number 273. Obviously, we're not going to expect people to memorize that, so instead we just use keycode dot up arrow, or you could use keycode dot like W if you wanted to get the W key, whatever you wanted. So we're going to stay with up arrow for up, makes sense. We're going to save again, make sure you do, and hit play. Go back. You can notice you can actually control your little Pong guy by hitting up arrow. So we're already halfway through making a game. Now we're just going to make him go down, which will be a simple matter. All you have to do is copy what you already made, paste it, get rid of the formatting that Visual Studio might try to do for you. Formatting honestly doesn't matter. I'm just trying to keep it consistent for the sake of this video. If you like your parentheses up over there, go for it. Luckily, your code is not going to care. But now we've copied our if statement, we're going to change up arrow to down arrow. Instead of adding that, we're going to subtract that amount. As you guys may be able to guess, is going to make our Pong guy go down. So we're going to switch back over to Unity. We're going to test it, and yep, he goes up and down. Pretty snazzy. But his speed's a little slow for what we're trying to do. So let's go back in here. Now, something very nice that Unity has that makes it very easy to test such things like speed or stuff that you want to change a bunch for play testing or other purposes. There's this very nice way of declaring variables that lets you do that very easily. So the way you do that is you whenever you're making a new variable, if you put serialize field before it in brackets, and then we're going to make a float called speed. So serialize field float speed. This is going to be a new variable that any of our little functions here can access, particularly this one. We're going to, instead of adding 0.1, we're going to add speed to the variable, and we'll actually make speed equal 0.1f by default, in case we don't actually put anything in. But the reason what the serialized field actually does is if you go back over to the editor after saving, and you check in our little script area, you can see it actually has a new field, speed, that we can edit directly. So let's say, 0.1's a little slow. Let's see how fast he goes that fast. We put it at 1, and it goes pretty dang fast, which isn't exactly perfect. So let's just say 0.2. So that's much more reasonable. And yes, you can also edit this while in play mode, which makes it pretty good for playtesting, especially since all of your stuff that you're changing over here doesn't get saved. So back to 0.2 now. So now that we have a nicely moving paddle at a fairly comfortable pace, we can now actually just copy this paddle, paste it, move the new one over. Now all of a sudden we have 2 paddles, one for each player. But you may notice a small problem is that whenever you hit play, both the paddles are controlled by the same keys, which don't exactly make for a very exciting game. So in order to fix this, we're going to go back to our code and add in some new fields up here. So these are also going to be serialized fields. We're going to make them type key codes. Make key code up, key code down. And now that we have these key codes we're going to be setting, we don't need to get the key codes from here anymore. So this key code will be up, and this key code will instead be down. So make sure you hit Control S, and what that does is something very fancy that Unity does nice for us. Once the script recompiles, you now can see we have these little fields over here. So for the right player, I always prefer their keys to be. So if you click on these, it'll show you pretty much every key on the keyboard imaginable. Huge list. You can simply just hit the up arrow. You can hit the first letter of the key you're looking for. Or in this case, we're looking for up arrow, so I'm going to hit U until I find it. There it is. One will be down arrow, so I'll hit D. There it is. And for the left one, I prefer W and S because that's how a lot of games you control your character. W, hit W until it works. There's only one key that begins with W, and that's W itself, so it automatically gets it. S has a couple more, so we have to hit it a couple times, and there it is. So, now that we've set the up key to W and the down key to S, this one, and the up key to up arrow and the down key to down arrow on here, should be able to be controlled by different keys, which they are. Which is pretty much, we now have a 2-player game, which is nice, as long as you guys don't mind sharing a keyboard. Which sadly will not be going over multi-controller support just yet. So, keep track of our paddles. We're going to name this one left paddle, and this one the right paddle. Be a bit more descriptive. It's always a good idea to name things as you go, because sooner or later you will have tons of these little game objects in here, especially it gets ridiculous how many of these you'll get eventually if you go into more complex games. So it's always good to name as you go because it's hard to remember paddle number 6 was supposed to be this thing. Alright, so now that we have both of our paddles good to go, you may notice one small problem with their movement, and that is that they can go off the screen, which is not ideal for Pong. So in order to fix something like that, we need to know exactly how far each paddle should be able to go. Pretty much make sure they keep on camera. Something that we have to do first is make sure every player plays at the same aspect ratio. So right now it's on free aspect, which is very much dependent on whatever size they make the window of your game, which is not what we want. We want it to actually be stuck at a certain resolution. This resolution we're going to make 4x3 because that's very much how Pong is usually played. That actually cut off one of our paddles, which is fine. That's an easy fix. You just click and drag it back onto the screen. So now we have a fixed aspect ratio. We can go ahead and discern what the top and bottom y coordinates would be for our paddles. So it seems the top coordinate would be about 4, which is, you can see over here by messing with this, and we can see that it goes off the screen at about 4. So we don't want it to go any higher than 4, and it looks like we don't want it to go any lower than -4. So that makes it pretty easy to remember 4 and -4. So we're going to go back to our code and do just that. So if get key down is that, it goes down, but after it's done both its up and downs, whatever the player may be inputting at the moment, let us make sure that it never goes above certain numbers. So pause.y, if it's ever greater than 4, so if it's ever higher than the value 4, we need it to be set back to 4. So if the player holds up while it's at 4, it'll get set to 4 point whatever speed is. I think speed's 0.2, so it'll be set to 4.2. It'll realize, oh, it's higher than 4, so it'll get set back down to 4. Pretty simple. I'm going to copy this, and paste it, and we're just going to flip this sign so it's ever less than -4. It's -4. So these two statements simply just bound it so it can never be greater than or less than negative, or never greater than 4, never less than -4. So it recompiles, play. Now our blocks are no longer able to fly off the screen. It's pretty good. That's pretty much almost it for the paddle controller. I actually believe that is entirely it. The only thing left to do with the paddles for now is to get them set in the right position so that they start in a fair field. We'll say -5.5. Yeah, 5.5 looks about good. You can set them closer to the center if you want. It's entirely up to you. And Y position 0. So 5.5 for him, and Y position. Now they are symmetrical. No player should have an advantage. Also, just a quick little thing I like to do is, if you click on the camera, you may notice that the background is blue by default. You go ahead and make that black just by bring up the color picker. You make it black, and it just looks much more Pong-like to me. It's very much a personal preference. Go with whatever your heart tells you. Just make sure whatever you do, make it, you can still see the paddles easily. Alright, so now that we do have two working paddles that are both constrained to the box they're currently in, we will make the other main aspect of Pong, and that is the ball you get to hit back and forth. So we're going to right click in our asset window, create a new sprite. We're going to make this one circle, and we're going to call it ball. We're going to drag the ball right into our scene view, and it starts out a little big compared to our paddles, so we're going to go and pretty much lower its size by changing its scale to 0.5, making it much more reasonable. And we're going to go ahead and make the script for it right away. So create a new C# script. We're going to call this one ball controller. Again, make sure you get the name right the first try, or you'll have to delete the script and try again. So double click on that. It'll open up in Visual Studio. It may give you something about this. We're just for it. It's just because Visual Studio, at least the version I have, does not like it when stuff changes without its knowledge. If you installed your Visual Studio with Unity, you should not have that problem. It should all be taken care of for you, but this one sadly does not play with Unity as well as the current version of Visual Studio. So, just like before, we start with our two classes, but this time we will actually make use of both, so keep them both around for now. We're going to, just like from our paddle controller, we're going to need a speed variable to see how fast our ball does go. And we know 0.2 works good for speed, so we're going to go and just make the default this. So now that we have the speed set up, we're going to go ahead and copy some code from here, from our paddle controller, into here. So we're going to grab the initial position of the ball, and we're going to edit that position a bit, and then set the position of the ball to the new position. So we're going to simply add to the x equals pause x plus speed, and pause.y equals pause.y plus speed. Real quick, just a little coder's trick. this is the exact same statement as this. These two are the exact same. Pretty much, it cuts you having to write out pos.y. So we're going to write all of our code in that new shorthand just to make it easier on our poor fingers. So plus equals speed. It'll be very helpful when you're writing a bunch of these all at once, so it's good to get in the habit of using shorthands like this just to save yourself some time. So now that we have that, the ball should fly off the screen once we actually attach the script to it, because right now it does not have the script on it, unlike our paddle controllers have their script, or the paddles have their paddle controller, ball needs its ball controller. We can add that either by using the add component, or this time we're going to actually just drag and drop the script from our assets folder onto the ball directly. And that goes ahead and adds it for us. So now we get play, watch the ball fly off the screen. I'm going to go ahead and lower this to 0.1. The speed, just to make it a little slower and easier to watch as we test, because since it's going diagonal, we're technically adding speed twice, which makes it faster than the paddles would be, so it's easier just to make it go a little bit slower. So now we got to make sure that the ball actually bounces off the top and bottom. But how do we keep track of whether the ball is supposed to be going up or down or left or right at any given time? We're going to actually just make some new variables just to keep track of that. So we're going to make an int. Int stands for an integer. Pretty much it's just a whole number, negative or positive. So like -1 is an integer, 1 is an integer, 1,000 would be an integer, -2 would be an integer, stuff like that. We're going to make an integer called horizontal. That's going to equal 1, and vertical, also going to equal 1. Now we're going to multiply our speed by horizontal for the x, vertical for the y. Now it may seem a little weird that we're just multiplying these by 1, but it'll make more sense in a second. So now that we have that, we need to know at what x value our ball is actually touching the top of the screen. So we're going to move this ball up here. Let's see that looks to be about 4.75 exactly is when it touches the top of the screen, yeah? And I'm going to guess that it's 4.75 for the -4.75 for the bottom, which also looks to be about true. So if pos.y is less than -4.75 or pos.y is greater than 4.75, then we will go ahead and set the vertical to be times -1, and so that will just flip the sign of the vertical, so that way now instead of adding the speed, it'll be adding the negative speed or just subtracting the speed. So if we go back into our ball preview, if we move the ball over to here, you can actually watch it bounce both off the top and then the bottom of the screen. Alright, so now obviously when the ball goes to either the left or the right, we don't want it to actually bounce back. We want it to instead give the players either a point and reset at the beginning. Right now we're just going to make it so it actually resets at the beginning. So if pos.x, of course we actually need the coordinate of when it flies off the screen. So let's see, when does it go completely off the screen? It looks to be about, go ahead and say 8 and -8. The reason we don't want to do it exactly when it gets off the screen is because it's good to give the players like an extra second just to realize it's off and it's about to come back to the middle. So we're going to make so whenever pos.x is greater than 8 or pos.x is less than -8. And we're also going to flip the horizontal sign, just because if it goes against one player, this means like if it flies off the right side of the screen, we're going to make it fly towards the left player, so that way it doesn't constantly score on the same player over and over and over again. And we will go ahead and make it so that way it goes back to its initial position. But how do we get its initial position? That is what we're going to use this for. So we're going to make a new variable called a vector3, which you guys should be familiar with by now, called initial position. So initial position, we're going to initialize it in the start function. The reason we have to do it in the start and we can't just do it up here like we have with all the others is because the ball doesn't actually exist yet, so its transform doesn't actually exist yet, therefore it doesn't actually have a position in space until this function is called. So we're going to go ahead and make initial position equal this dot transform dot position. So that grabs the very start of wherever the ball is at the current first frame of the game, and we're going to go ahead and make position equal the initial position. Now, if we go back to the game after we save, you should notice that the ball comes back to the center of the screen, and well, not the center in this case since we put it up over here, but close to the center. Put it right there if we want. Just like that, and reverses the direction whenever people get a point. So now that we have that settled, we can go back to the code, and pretty much that means the ball is almost done, except for probably the most important part is how do we actually make it hit the paddles. So in order to actually make it hit the paddles, we're gonna have to go back to the paddles and make sure we do this. This part is very important, so make sure you follow closely and do all these steps. We're going to add a new component to these paddles. Not opening up that. We're going to add these new components to the paddles. We're going to call them 2D box colliders, or box collider 2D. Pretty much, and you're just going to hit enter and add that. So pretty much what these do is this pretty much is how Unity keeps track of what's touching what. If something hits this, it'll send out a little trigger. If we check this little box called is trigger. So now Unity knows to watch out for if something hits that, to do something with it. It automatically shapes itself to the box. Since we're using very simple shapes, we don't have to like custom make these, we don't have to edit the colliders at all. They automatically fill out the shapes. So now the left paddle has one, so we're going to make sure the right paddle has one. Same thing, also make it a trigger. So default settings on these 2D box colliders, except for the fact that they are both triggers. Make sure you make them both triggers. So once they both have theirs, we're going to open up the ball. We're going to give it its own collider, though of course we're going to give it a circle collider, which also already fits the ball perfectly. Since it's such a simple shape, Unity already knows how to do that. This one will not be a trigger. It actually doesn't matter if you call this one a trigger or not, but this one, because it's not actually going to be the one detecting, it's just going to be, it's required to make sure that Unity knows also to watch out for if this hits anything. So if this collides with anything else. Hint on the word collider. Also very important is that we have a rigid body, specifically on the ball. What rigid body does is mean that Unity now knows to also track this as a kind of physics object. Now obviously the ball, we're not going to give it any physics. We don't want it to be affected by gravity or anything. So in order to ensure that, we're going to get rid of all the angular drag, which is something Unity gives it to make sure that it behaves as if there was actually air resistance and whatnot. And we're going to turn the gravity scale off by putting it to 0, because we don't actually want it to be set by gravity. So make sure angular drag and gravity scale are both 0. We're also going to set the collision detection to continuous. If it was discrete, it would check, I believe, every frame. Continuous checks even between frames to make absolutely sure that the collision is perfect, pretty much. Make sure that it will never, it will collide as many times, or it'll check for collisions as many times as it can, which is really good for making stuff sure things are reactive. Or if you're like making a platformer, you don't want the character to accidentally bump into a platform without neglecting its collision. Very important you make this continuous, make it more reactive. We're not going to turn off anything, we're not going to edit anything else, everything else is fine, because we're not actually going to be using the physics part of it. If you were, you might want to change a couple of this stuff, but since we're just making very simple coordinate changes to its transform, we don't actually care much about any of this, besides the fact making sure it's not affected by gravity. So now that we have all of that, that allows us the ability to add into our ball script a whole new function called void on trigger enter 2D, and it's going to take a collider 2D as its first parameter, or no, it's going to take a collider 2D as its parameter with the name of other, and there, give it the proper parentheses. Okay. So now that we have this new fancy function, so what this does is pretty much anytime our collider we put on the ball enters a trigger, it will now get that trigger and pass it to this function as a parameter. So, and since we made it continuous, or yes, since we made it continuous, through this. It will do that even between frames. It'll do it a lot. So we will never miss the chance when the ball enters in to a trigger. Particularly, the only triggers on our game right now are the paddles. So if the ball enters in on the paddles, all we want it to do really is to just flip which way it's going horizontally. So horizontal times equals -1. Looks like I turn on insert mode. Okay, so horizontal times equals -1. That should now make the ball be able to bounce between paddles. And it does. So we pretty much already have a working version of Pong, which is pretty nice. So this version will be very basic, so infinite loops like this will be a little hard to avoid. But if you want, that is a future bit of project practice you can do, is if you want to try to change how we make the ball move around to actually affect the ball, so it might speed up or might change directions randomly. You may even make it so it doesn't move just diagonally, but also kind of like certain directions. You do a lot of things to make this so it's not so basic, but for now, that is something we'll let you explore on your own. We will teach you, though, how to actually set up the scoreboard for your Pong. So we have the basic functionality of all this. Now we just need to add the UI. So we're going to right-click in the hierarchy, right UI, and text. And now it is going to add this big, huge, compared to our game, thing called a canvas. What this is it's pretty much another kind of camera. Anything that's in the canvas will be layered on top of our game camera. It's pretty much made for things that aren't actually supposed to physically exist in your game world. So our Pongs and paddles obviously do exist. They have interactions and whatnot, but the text on our screen won't interact with anything. It's just UI elements such as a health bar or how much money you have, or a menu. All that stuff isn't really in the game world, so it's put in the canvas. The canvas, it's huge compared to the camera, but that doesn't actually mean anything. It will automatically be layered on top of the camera and be fit to the resolution and everything. Unity handles all that on its own. It just looks a little confusing at first because this is our game down here that we've been working on this whole time, and this is the canvas where our text is going to. We're going to go and change the name of the text to scoreboard. Because again, name stuff as you go, so you don't get confused. We're going to go and change the color to something we can actually see against this background, so we're going to make it white. You can now see we have new text. We're going to change the sample text that it has, the little preview text, to something that actually represents what our scoreboard will look like. So we're going to make it 0 space 0. We're going to change its alignment to centered, just so it's it's centered like a scoreboard. We're going to make its font size 30. Now notice we made the font too big, so it's actually too big for the text box. We're going to go ahead and make sure that this tool is selected so you can actually scale the text box. And we're going to click and drag and make it bigger. Recenter it. Alright, so now we have a nice scoreboard. If we hit play, we can already go ahead and see. Yeah, full scoreboard has appeared for us. That's still a little tiny, so we're actually going to bump this up to, say, 50. There we go. You want your score to be impressive. You want people to know when they're doing good versus when they're doing bad. So, now that we have that, we need to actually make it reflect the current score. So in order to do that, we need to keep track of the current score. So we're going to go and do that in the ball controller. This is a little much for one single script to take care of all of it, but since this is such a simple game and none of the scripts are really doing that much, it's not too big of a deal that we're keeping track of all this information in one. So we're going to make some new ints. We're going to make them P1 score and P2 score. And they're of course going to both be initialized to 0. Because obviously you don't want anyone to start with any points. That'd be rather silly. We also need to grab the text box that we're going to be using. So in order to do that, we're going to make a whole new serialized field. It's going to be of type text, not text alignment, just text, and it's going to be called scoreboard. Now there's a small problem here in that we don't automatically recognize this size tag. So unlike Vector 3, which is a class that Unity Engine automatically provides for us, we need to import text somehow. So in order to do that, in order to grab the text class, we're going to be using the Unity Engine.ui. Capital Y. So, Unity Engine.ui. And then it will automatically recognize, oh, text is from there. So, now that we have that, all we're going to simply do is take this text object scoreboard.text. We're going to set it equal to P1 score plus some spacing in between P2 score. plus. So just some quick more coding tips. Pretty much what this means is that, so P1 score, the number, will be added to the string. So when you add something to a string, it means you just pretty much stick it on there. So this will automatically be converted to a string, and a string is just a bunch, like a series of characters. It's like just some words. So like this will simply just put the score into a string, put a bunch of spaces next, and put the other player's score. So we should be able to see that if we actually make this. Let's say we just make 1 for now, just for testing. So let's see. Test it to 1. Doesn't, because alright, so we made that serialized field, and it's actually over here now, but we never actually initialized it. So how do we make sure that this text field is corresponding to this scoreboard? And the way to do that is actually pretty easy, because we just simply click and drag on top of there. So now this scoreboard is now related to our text. We're grabbing it through here, and it is now this variable that we have in our ball thing. We're going to set its text to the player score. So we hit play, we actually see that it works. And we successfully set the scoreboard to what we want it to be. So now we actually need to keep track of the player's score. In order to do that, we're going to, instead of, so we notice that whenever it goes left or right off this field, we simply make it switch positions. Well, now we want it to do separate things if it goes left or right. So we're going to split this statement up into 2 separate if statements. So this one's going to be closed off like that. And then we're going to add an if here, like that. So we have 2 separate if statements. So however, in either situation, we want this to be like that. We want it to be, the horizontal will be switched and it to start back at the original position. But if it does fly off to the left, this would be, since it's going, no, this would be to the right, so that means the player on the left just scored a point, and we'll make them player 1, so P1 score plus plus, which just means plus 1. And this one will be P2 score plus plus, which just again means P2 score plus 1. So if we hit save, go back to Unity, you hit play, you'll now see that each player can now score the ball, and players can hit it back and forth. It'll very easily get stuck in an infinite loop. That is again something you might want to try to change after we're done with this course, but it is a very simple version of Pong that you have completely made from scratch. That brings us to the end of this workshop. Congratulations on making your very first game in Unity. Feel free again to experiment, see if you can make it a bit more interesting, make the ball speed up, all that kind of jazz, or just change the colors of it if that's what you want. Always room to explore here. If you have any questions or comments, feel free to email us or even see us in person, as we hold these workshops every other week. The next one will be on October 9th. They're all held in room 210 of Building 4 on the UWF campus. They start at 6 o'clock and run around till 8 usually. The next couple we will be doing are all going to be linked together, and hopefully to and allow us to take you by the step-by-step process for making a much more complex game. Much more complex than Pong. That's why it will take up multiple sessions, but we hope it'll be much more interesting as we get into the more finer aspects of Unity, as we've only just scratched the surface. Of course, there are also tons of other resources online if you want to learn more. We always encourage stuff like that. Google is your best friend for finding this out, but if you have any suggestions or, again, comments or questions, feel free to email us or leave a comment. Thank you for watching, and I hope you see you at the next one.